Let me know. Push button selector switches, joysticks, limit switch, daylight switches, pressure switches, temperature switches, flow switches, smoke, gas fish switches, liquid level, wind metering, automated systems, troubleshooting control devices, and smart integration. So we'll get a little bit into our solid state devices, but these are devices that set over on that left-hand side before we get to the load, right? You understand that? Between L1 and load. Push buttons, you should be okay. And I think our push button panel is. This was the old motor control trainers. So when we first went away from the relays out on the table. So when I came here and took motor controls, we just had a bunch of drawers and had a bunch of relays in it. And when we got a lab, we'd have to go to the drawers and find the relays that we wanted, and we'd set them on the table. And then we have a 3-phase circuit breaker up there. And it was in this room right here, by the way, and you had a bunch of wire, and you just wired them together. And then the second trainers we went that we had built for us was this one here, and then the stand-up panel back there on the back, a big gray panel. That's one first one we did. We steer wired with wire, and we found out real fast that men and screws just don't get along with each other. They strip them out and all kinds of stuff. So then we got this company, Triple Imco, to design this for us. So this was designed for us, and Imco sold the rights to it. Now a company called IEC. It's on your textbook. These are the guys that actually build the trainers for us. Oh, it's IEC or something. It's on the front of the lab book. I'm sorry, or in there somewhere.
ECI.
ECI.
Is like.
So we have a contact block. This might be included or it might be changeable, right? Then we have the actual operator itself. And we normally have a legend plate. The legend plate is written on there what the push button does. And then we have the, I don't know what exactly it's called. These come in different forms. And then we have, this is the actual operator. So this is the plunger that pushes in.
That's the actual ring that screws on.
Yeah, but you can get different rings.
Yeah.
You can get countersunk rings, so the push button is not
flush.
Yeah, it's flush. See, then you can get these rings right here. Look at this ring.
Yeah.
This actually leaves the push button exposed. Yeah. Then you can have one that's opened up on the bottom, and it's got, and these are for gloves, so people can hit them with gloves. And what's nice about these flush like this one is that if you accidentally hit them, you can't do that. Now your e-stop buttons can't use these. I got to use this mushroom hit switch. You can accidentally hit these things, right? You understand? By the way, another feature of an e-stop button is it is not a momentary contact button. You can see what happens up here when I hit the e-stop. What do I have to do? It latches down, right? You understand? And I got to literally do you got to pull it back out. So it can't be a momentary contact. So this is pretty much and like I said, most of your nice ones will have the contact blocks will be replaceable. So if you got a problem with your contact block, you can replace it without replacing the whole switch. In electronics, it sometimes get a bug because just about all the switch push buttons and everything are soldered in. But not only do you have to take it apart, you got to resolder the contact. So we got a stack of the switch blocks over here. And so the ones that we have, I didn't hook up my external camera, so I'll have to use the camera on my own. So what's nice about these is you can basically build the switch that you want. You'll see them. So these are actually replaceable contact blocks. and there's one contact within each switch and within each block. So, and then the operator comes through. So you can literally stack these things up. So you can have a lot of push buttons, contacts on a single operator, right? And that's very popular. I think there's a big stack of over here. Maybe stack on top of it. You can see. I'm not even sure they're screwed down. I think they just stuck them there. Of course, ours has legend plates on them, but on ours, you kind of ignore the legend plate and use, if you need a normally open switch, you find a normally open switch, right? Or later on, you might need to start a selector switch. The operator is a device that is pressed, pulled, or rotated by the individual operating circuit. That makes sense. Any questions on that? Contact blocks include normally open, normally closed, or both normally open contacts. And a lot of them you run into in industry, just about all your push buttons are what we call double break, double make contacts. And what's the advantage of those?
One side fuses shut.
Yeah, one side welds and it rocks and will open up. A push button station is an enclosure that protects the push button contact block and the wiring from dust, dirt, water, and corrosive fluid. So this wouldn't be a push button station, right? Of course, this we had to get to it to actually wire them. Your push button stations would be like this, right? So they're actually sealed into an enclosure that helps keep moisture and dust out. And also it helps contain the fire if one of these things burns up on you. A two-position selector switch allows the operator to select one of two circuits. Are we okay there? And of course, selector switches are manually operated. This is one of the very few switches you'll actually see. We use a lot of push buttons and then selector switch. And of course, what's this assembled for?
Temperature.
Temperature. Which would be a sensor that senses. Are y'all okay here? Couldn't y'all see how it works? So here's the way they represent which contacts closes. Up here on auto, they have a dashed line. This is the contact that would close when you put it on auto. This one has a solid line, so this contact would open when you put it on auto. It would close when you put it on hand. Y'all understand that? So we switch it on auto, then the heater is controlled by the temperature switch. If we put it on hand, then it's manually controlled by the switch. Three position, this is what we have, a three position, a selector switch. A lot of times we use it as a single position. To use it as a single position, of course, depends on what you want. We can use auto and manual, or we can use our two position. And then, of course, then we just switch them between the two. I think the one that y'all do is you're just switching it between manual and off, right? Something like that. So here we have the ability to turn the system off. You can't run it in manual, or you can't run it in auto. When you see what they've done here on this symbol, they put the little circles up to off, and then they're showing that this is the position it would be if you put it in off. Are you okay? Yay, nay?
Yay.
Okay. We get into more complicated switches, what they'll do a lot of times is they'll contact position selector switch may be integrated using what we call a truth table or target table. Truth table will determine that we pick up a digital. Target tables are also used, or solid lines, dash lines, and a series of small circles. So the first one would be what we call a truth table or a target table. And what we have is we have a selector switch up there. We got two positions, position 1 and position 6. And I guess I need to be marking on the slide. So I'm talking about this first one up here. Okay. So this is kind of using what the US Steel thing does, right? But they actually put the X's over here on the line. Over here, this is a truth table. So it says if I put it in position 1, then what would happen? Then A would close and B would be what? Open. If I put it in position 2, then B would close and A would be open. That makes sense? The next one is a 3-position selector switch. So here it's saying if I put it in position 1, A would be selected. If I put it in position 2, then neither one of them would be selected, right? You understand that?
That X is meaning closed?
Yes, the X means closed. And that's what it says. X indicates contacts are closed. A 0 can be used to indicate the contacts are open. Sometimes I've even seen them where they're blanks. Are you okay? What page is this on at, by the way? 292. 292. So you've got these same figures. It'd be easier, if you need to see them, just to look at them in the textbook. So in position 2, both A and B are open. In position 3, then B is closed and A is open. Are you okay there? And then the last one uses the dots and the dashes that we've already seen.
And this is switch is going to be manual and auto also.
What's that?
Switches is going to be manual and auto.
Well, no, these are just 3-position switches. They can be, the legend plate can mean them anything. It might say run, jog, and stop, or it might be something like that. So all they're doing is giving, when they sell you the switch, they have no idea what you're going to use it for. So when they do this on a switch, they don't give you run, auto, manual, because they don't know what you're going to use the switch for, right? You know what I'm saying? It's just like you go down to AutoZone and you go up to electricity. They've got all types of switches over there, but all they do is turn things on and turn things off. They have no idea what you're going to use that switch for, right?
Like when you see it, like you do troubleshooting, when you see it in the diagram.
When you see it in the diagram, it would be labeled something. But this is the label that would come when you buy the switch. Okay, does that make sense? Because the manufacturer of the switch, it's a 3-position selector switch. What can you use it for? Well, anything you need a 3-position selector switch for, right? You understand? One of them might be turn the sump pump on, and that's what you would label that once you put it in your application. But the manufacturer has no idea, so they give you these truth tables to show you what makes depending on what position you put that switch in. Does that make sense? It's just like when we did these, we put these little markers up here. So you got a selector switch, and then you could come in and you could write on the legend plate whatever you want, whatever you're using that switch for. Now, this company here, they went ahead and put a legend plate up there, but you've used the push button that says stop. You've used it to turn a light off, right? You understand? What does turning a light off have to do with stop, right? You understand? So y'all use these switches, those push buttons, you've used those for different applications besides what's on that legend plate up there. And all they're trying to do is just give you an example of what legend plates look like. So when you go out there and you buy this switch from this company, it's going to come with a little sheet of paper usually that gives you this right here. And this tells you, okay, whatever I want to run when I put it in position 1, then I want to hook that up to I'm going to hook that up to this guy right here, right? The A contact. Position 2 would turn it off, and position 3 would close this right here. Then it's up to you to write the legend on it. And all this is picking up relay 1, this is picking up relay 2. What are those relays doing? You know, it depends on the application. Does that make sense? Understand? Now this is the one that we've already looked at where they're using solid lines to indicate one contact. They're using these circles to indicate when we put it in the center position, and then they're using the dash line to indicate the bottom position. So all 3 of these techniques are used when you buy the switch, right? Does that make sense? Everybody okay? Everybody here is familiar with jogs switches, joy switches. A joy switch is used to control many different circuits operations from one location. You have 3-position jog switch. Most of your games use just 4-position. Well, most of them use 6-position or 8-position jog stick. Joystick. What I mean?
I say those going to be in the test.
No, these are not going to be the symbol for the 3-position jog switch will be, but this will be on the 3rd test. So what we're doing tonight won't be on Thursday's test. So you should ask me those questions again. So these are joysticks. So they give you a truth table. So up here on your truth table, if you move it to the right, it says it's going to close contact A. If you move it to the left, it's going to close contact B. If you move it up, it's going to close contact C. If you move it down, it's going to close contact B. And you'll see these in all type of earth moving equipment. You'll see them on cranes. These joysticks will be on cranes. Right.
What about those joysticks like that? The farther you push it one way, the faster it goes.
Those are what we call proportional joysticks. Those are analog joysticks. These are not analog joysticks. These are motor controls. So analog means we have the ability to move it between a range, right? You understand that? In a motor control system, we don't handle analog devices on most motor controls. If I need analog devices, we're going to have to take the analog device and somehow convert it over to 1s and 0s. So all your motor control circuits are looking for are what? They're either what? Open or close, off or on, or stuff like that. So you're talking about a proportional control.
Yeah, well, let's say joystick on our grinders, go to a PLC.
Go to the PLC, it's got an analog input. Yeah. Or you've got an analog module, which takes it and converts it into this kind of stuff. But that's a good question, and a lot of video games have that, where not only can you control the direction, you also can do what? Control the speed. But that's not a motor control circuit, that's a computer. So most of the joysticks that we run into in a motor control circuit, because we're controlling motors, is they're going to be either on or off. And then we would control the speed. We can control the speed of a DC motor by stepping in relays. So a DC motor, we can control the DC motor by just stepping in resistors. So the old cranes we used to work on, the older cranes, what they would do is out here on your power circuit, they would just have a set of resistors. And then it would come over here, and then you would have your armature for your DC motor over here. Now this is the power circuit, this is not the control circuit. And then what they would do is they would put contacts right here. By the way, how many did I tell y'all if you didn't put the dots, you didn't have a connection? How many people think they did that on the diagrams they had to draw for them? So this might be called speed 1, this might be called speed 2, and this might be called speed 3, and this might be called speed 4. And you'll see how this works. And over on your motor control, you might have a joystick that's got 3 positions, right, or a selector switch, speed 1, speed 2, speed 3. But the motor moves in speeds. And all you're doing here is just cutting out resistors by bringing in these contacts. Now this would be inside a control circuit. But we're still kind of digital because we're still moving in steps.
That's what our cranes do.
All the cranes do this all the time. You have 5-speed cranes, and
Even the remote boxes.
it has 5 speeds on them. You got 5 little click, yeah.
Radio control.
And that's basically, and if you was up on the crane, on the older cranes, you would actually see these relays kick in, and they'd have the big old resistor banks up there. They have cooling fins on them because they get kind of hot. Like trains. Trains use a type of motor called a wound rotor motor. And what they do is they use resistors to change and it works on the same principle. So trains have set speeds. And they click them.
Just going off the subject, I tell you that the trains now have car alarms on them.
Has car.
I kid you not, the other weekend I was there by myself and I heard, wah.
Somebody was trying to break
And
it.
it went for 5 minutes, they couldn't get it shut off. They turned it off, turned it back on, and started it all
I don't blame you, man. Somebody get in there and mess with those things. They can kill somebody. Yeah, so the trains work this way too. And that's what that big old fin thing that sticks across the top. You know, you see if you look at the train from the side, it's got these things that come across the top and go like that. And then the train is right in here. That's where all your resistor packs are up in that section up there, and that's where you can get air. You see it's got
big
vents.
huge fan in the front.
Got a big used fan blowing across there to keep those big old things cool. So this is a way we can do this in motor control, but this is not proportional speed control. This is moving it in what? In steps. And for years, a wound rotor motor was the only motor you could control. AC, you could control the speed of the motor without changing the number of poles. So there is a motor out there you can control the speed by changing the resistance of the rotor, which is pretty neat. Called a wound rotor motor. Wound rotor motor. Wound rotor. And that's exactly what it means. The rotor is wound, so it's an induction motor, but the rotor is wound, and you have slip rings on it, and you come out and you can change the resistance of the rotor, which means the motor will have to run at a different speed so you control the slip is what you're doing. Now this one on the bottom, this is another method where they just put a dot on here to indicate. So here's your joystick right here. It's 1, 2, 3, 4 position joystick, and it says, okay, if I move it to the right, then this contact will close. If I move it to the left, this contact will close. Gang, I need to get. So if I move it to the right, then this one's going to close, right? If I move it to the left, then this one will close. If I move it up or away from me, then this one will close. If I move it down, then this one will close. So this is just another method of indicating these joysticks. And we have these all over the place. If you get on any new crane, you're going to see joysticks on them, right? Earth moving equipment is going to have joysticks in it. Get on the farm equipment. Get on farm equipment that these harvesters and everything. They're going to have joysticks on them. You get in a jet airplane, it's going to have a joystick in it, but it's going to be a proportional joystick. Your F-16 is controlled by a joystick. It's over here on the right hand side, so they don't have a stick in the center. I don't know about the new one. Hadn't been out of airplanes in a long time. Limit switches were already okay there, right? Limit switch is a mechanical input that requires physical contact between the object and the switch actuator. And if you get out in an industrial application, you're gonna see these suckers all over the place. We've already looked at the symbols, right? Normally open, normally closed, normally open, held closed, normally closed, held open. Y'all wanna go back over those? So everybody okay on the normally open, held, the normally open, the normally closed, and then the normally closed, held open, and the normally open, held closed. And like I said, the solid state limit switches are nice, but they cost so much more than your regular mechanical limit. And plus, it's hard to get a solid state limit switch that carries a lot of current. Are we okay? Are y'all still working on that? Want me to pause it? Because I want y'all to listen to me. When we go over to the manufacturing line, so when we get through with the lecture, this chapter right here, what we'll do at the start of one class is we'll meet over at the robotics lab, and we have a manufacturing line over there. It's not big, it's really neat, and it's got all these sensors, and it's got limit switches, and it's got capacitive sensors and inductive sensors. It's got light sensors, optical sensors. We'll go over there and
Well, they got so many things on that thing to stop the line down there. It's like there's a spot he says, don't walk that way. Why? More people stop the line by walking through that area because they have a little optic sensor on the floor.
Yeah, to protect people. A cam operated limit switch must be installed to prevent severe impact and allow a. So what they're saying, most of the time when we put these limit switches, we bring them in, we actuate them with either an incline, right? You understand that, or we actuate them with a cam that's got a. So we don't do this kind of stuff. We want to actuate them gradually. We don't like to hit them real hard. That make sense? Everybody okay? Most of this is common sense. Limit switches using push rotor actuators must not be operated beyond their travel limits, but that's true also for the rotor. And all it means is just mounting them too close to what they are, or mounting them. So you need to always check these things, to make sure when you put them in there that they're not going to exceed their travel. Limit switches should be mounted to avoid accidental activation, accumulation of material, and excessive heat. So you notice on the top they've got what I was talking about. So this would be bad, right? This would be good, right? The top one, that would be bad. So you need to put covers over these things, or put something where people can't accidentally do what. Oh yeah, I mean, I don't know what it is about guys, but we have this mentality: if we see a knob, we're going to have to do what? Turn it. We see a push button, we're going to do what? Press it. We see this little operator up there, then we'll go over and say, what does that do? And we'll hit that thing, So we try to guard these things so guys can't get to them. It always surprises me, Hey, what does this do?
See, that caused a leak on the big panic in the robot lab because it had a little knob that we shut. And water came out of it.
Oh yeah, that was of course there was nothing hooked up to it, but it still
Just
had
old water.
It still had the water in the pipe, so. Are we okay? This should make sense. So we need to do something to keep them from being accidentally actuated, right? We need to put them in places where they're not going to be exposed to a lot of material or and we need to not expose them in direct heat. And notice all they did here is they just took it on the top and they moved it where? To the bottom. Changed it from a normally open to a normally closed, or vice versa. A foot switch. I got one of these at the house, by the way. I took it off an old sewing machine. A foot switch is used to allow hand-free control or an additional control point. You see these things all the time on how it's made. You can't really see it. These people will be coming over here to these big old gaming machines, and they'll stick the thing in there, and all of a sudden it closes. And they got both their hands up on there. Well, how do they close? They got it down on the floor, they got a roll. And they got a flip switch. So you see these things used a lot. Normally they're used where the operator has to be using the two hands for something else, right? That makes sense? So the first one shows me a closed when pressed a limit switch, and then this would be a heel toe limit switch. Some of your motorcycles, the big old Harleys, have heel toe shifters.
Up and down?
Well, to shift up, you raise it up. The shift down, you push down. Well, on most motorcycles, you have to shift your toe around. So you put it on top of the shifter to shift down, and below it to shift up. Well, some of the big old Harleys just got a heel toe shift.
How many speed on the motorcycle?
It depends. Mine was a 6-speed. Mine is
It's
6-speed.
all in your lane. How are you gonna know which one is gonna be which speed? From what? From
Practice.
speeding?
No, just for using it.
Practice.
Well, what happens is that the way it's set up, you don't have a position. So if you're in first and you hit it once, you go to second. You hit it again, you go to third. You hit it again, you go to fourth. You hit it fifth. So it shifts one gear for every time you hit it. It's got a ratchet assembly in there that shifts a gear. And that's also true when you go down. And neutral is in between first and second. You get it in neutral, you get it in first, you just barely click it and it'll go into the second. But you don't, there's no shifter that says first, second, and third. It's just that every time you hit the shift going up, it shifts to the next higher gear.
Okay, it's not gonna be 1, 2, 3.
No.
It's gonna be
1, 2, 3. Yeah. And then down, if you hit on the top of it, then you shift down.
Shit, make it back into that.
And that's the way most of your, I don't know if you've seen like these Indy cars, they have a little paddle shifter on the side, and that's all they do to shift up is they just hit it and they shift down with the other shifter over there. They don't have very much room for a clutch. So yeah, you don't have different positions.
Yeah, I drive a motorcycle one in my life.
Oh really?
Yeah, but I don't know how to do it. This is the shift. I just keep doing it till get speed, one speed, and I keep on the same.
That's what you got.
I never change it. When I stopped from the hand, and then I give it to them.
So you said, this thing's crazy, I'm not gonna ride with it. Of course, that's what happened to me. I know I got hit in my motorcycle. That's why I'm in this wheelchair.
They say it's a danger.
It's not if, it's a when.
Well,
That's what every motorcyclist I've talked to. Not if, it's when.
well, the way I look at it, when it's your time, it's your time.
I was down at the shopping center on exit 1, 459. I was just sitting there watching, and this old lady, this guy was just driving along, and this old lady must have been talking to him. There's no way she couldn't have seen him. Just turned, she turned right into him. I just saw him hit. I was saying, oh gosh, that man did not deserve what she did to him.
Yeah.
Yeah, it's dangerous. The motorcycle is very dangerous thing.
I didn't get any closer. There ended up 20 people mopping the thing, trying to help.
A daylight switch is a switch that automatic. Most people refer to these as photo cells.
Yeah.
These are solid state.
They call them solid state.
They are
They
solid
are
state.
solid state.
Solid state is a term that we use to mean it's electronic. It's not mechanical, it's electronic.
No moving parts.
There's no moving parts in it. And that's why, so anytime you hear somebody say solid state, it means it's an electronic device. It's not a mechanical device.
I call them solar.
Well, solar cells are cells that produce voltage. A photo cell is a switch. That's all it is. And anytime you see a symbol that's inside a diamond shape like that, it means it is solid state. So we use basically the same symbols. So what does the diamond mean? Yeah. So that's the term they use in motor controls. They call it solid state. They don't call it electronic.
And the motion is same? The motion sensor switch is going to be solid state?
Yes, so motion sensors are solid state. They've got to be electronic, right?
Yeah.
The solar cells, those are definitely electronic. And we have the solid state limit switches, those are electronic. Now the problem with electronics most of the time is that instead of having 2 wires coming into it, we got to have 3 wires because you got to power the electronics up. If the electronics is going to sense light, then the electronics is going to have power on it so it can do what? It can sense light.
Yeah. If you don't put the nozzle on, it never works.
Yeah, it'll never work. Now your solid state limit switches are different. They use a lot less current, but all these sensors like this. So see this right here, the L1 is also what we're switching, but we got to hook up this L2. Why do we got to hook up the L2? To make it work, to power it up, right? You understand? It's just like your car radio. You know, your car radio don't work unless you turn your car on, right? And then once we do that, when it senses light, then the switch will close. And then in this situation right here, all it'll do is it'll turn in a lamp. Now, one of the problems we have is most of your solid state limit switches only have 1 or 2 contacts on them. Some of them only have 1. Right? You understand that? Now, I didn't say always, like the book says. I said what? I used the term usually. With these devices, they usually only have 1 contact, but that's no big deal because we could use that 1 contact to bring in a control relay, right? You understand? And that control relay could have a lot of normally opens and it could have a lot of normally closed. I think ours has 3 normally opens and 3 normally closed. So, and you run into these all the time. All your street lights out there have these solar sensors, have these solid state light sensors on them. So what do? Before they came out with these things, these banks and these grocery stores and everything had their lights on timers. The timers have been around for years. Just a little synchronous motor that goes around and flips switches.
They still use it for the high voltage.
Well,
the timer.
They don't have to do that. No, they could use these.
For the high voltage?
Right, but they could do the high voltage with a relay. No, there's still not a timer on. I mean, you can go out on every one of these street lights out here, and you could climb up on that pole, and you'd see a little old window in there with a solar sensor on it. I mean, I've worked on a lot of street lights, and that's pretty high voltage there, right? You understand? And you can tell the ones that run on a timer. How can you tell the ones that run on a timer? Because in the summertime, they'll come on at 5 o'clock. Or in the wintertime, they come on at 8. And that's what's nice about having these photo sensors. Yeah, we can use these things to pick up a relay, right? You understand? Now, the way they work inside these street lights.
I get idea now.
Huh?
You give me some idea.
Yeah,
I have something in my head.
We're in trouble.
Yeah.
Yeah, you know, your relays can control high voltage.
Yeah.
You know, so you could have a little relay that's got a 24-volt coil on it, but the contact on it can be rated at like a compressor, compressor relay on an HVAC system. That's 240, quite a bit of current. Oh man.
Get ready for the grid to go down. How many's got that?
Yeah, I'm going to do something on this.
Just make sure it's not on my grid, okay?
And you can buy
your own grid.
You can go down to Lowe's. You can go to Lowe's and you can buy just the daylight sensor. You can buy just the daylight sensor.
They have it.
And it has,
they have a 3-wire on it.
Yeah, and
you
then
can put it anywhere.
Then you take the output of that thing and have it do what?
Relay, and I control the whole outside light.
Yes.
Like the mad scientist.
Yeah, your motion detector detecting lights. That's what I have on my house.
Yeah, you scare me, man. He's a mad scientist.
The motion detector lights, they work off. They have a solar cell on them that only make them come on at night, and then they include a motion detector that comes in the play. And yeah,
They're handed. Darkness and motion.
yeah, dark. It's got to be dark and motion. Yeah, I've got them things all over the place. Out on my shelves.
Dark sensor. Dark.
Motion.
It's not a light sensor. Darkness.
Did they have them on how many minutes it's gonna take to be on and off?
No, most of them is instant on, instant off. But
There's no way to say how many minutes it takes them to be on and off.
You can always have
yes, not on the regular sensors that I know of. But if you buy the motion detector lights, you can set how long they are on, right?
Yeah, I'm talking about this is the switches. They don't have time about how long it take
You can buy
to
yourself
be
a timer.
just to be coming on. It take maybe sometimes 2 minutes, 3 minutes, 5 minutes, 10 minutes.
No, these just come on at night and go off during the day.
Yeah, that's what I'm saying. The night, But sometimes I try to test it. I have to put my finger, but it doesn't test by the finger, and I have to put some.
No, these are the motion detectors that you're talking about.
It's the same thing.
Now these are just flat daylight testers. Now there are some up there. So I've got one on my house that the lights don't come on. They come on slowly. And of course those are nice because it makes the light bulbs last longer. Usually a light bulb blows when you do when you turn it on, because you put that shock into them. Those incandescent bulbs, they have very low resistance. They get their resistance from heat. So when you first turn the bulb on, they have an inrush current, right? You understand? And so that's why they usually glow. That's why lights usually glow when you do when you turn them on. So this one is really neat because you'll walk under the motion detector and they come on slowly. But most of your motion detector lights have a test feature that when you put it in test, it enables the motion detector, but it disables the daylight detector. And of course, you could take that unit and use the light socket, right, to energize something else, right? So you could buy a regular motion detector light and don't put lights in the socket. Just get you a screw-in socket and then bring the wires out and use that to run a relay, right? And then you got a motion detector that's running 15 lights, right?
Yeah, that's what I'm saying now. But you can use it for all the outside lights.
Yeah, you could.
You can use one all.
Yes, you can use one.
There goes the grid.
But just take the socket off and then use the two wires that control.
They have it. They sell it separate with the three wire on.
A pressure switch is a control switch that detects a set amount of force and activates electrical contacts when the set amount of force is reached. And the example they use is the pressure switch on a compressor.
And or water also.
Water, right? We can use them to check water pressure. Yeah, we can use them to check any fluids, either it be a liquid or a gas. We can have pressure detectors that do that. And detecting pressure is very, very important in a lot of situations.
I have one today. I just see it.
Well, we have because when things start heating up, they start expanding, and of course, pressure is multiplied, right? Force. Anybody know what force is equal to? What is force? How would you define force? No, you're talking about power. Force is equal to the area times the pressure. And you get into these high pressure systems that have a lot of area, then you can really. That's why even though tornadoes don't create a lot of pressure, comparatively they push in against a lot. a lot of area. And that creates a lot of force. Force is a something that causes an item to try to change direction. So usually force creates motion. So you can't have motion without a force. And you can't have force without what? Pressure. And you can't create a force unless it's pushing against an area. So that's why they have pressure switches. Of course, they have pressure release valves on your compressor. If the pressure gets up so much, to keep your tank from blowing up. Did y'all see the Mythbusters exercise where they got a water tank, a hot water heater, electric hot water heater, and plugged up the pressure, and then they overrode the heater and made it really heat up, and they launched that thing out the roof of the building. Did y'all see that?
What's a hot water heater?
Huh?
What's a hot water heater?
You don't know what a hot water heater is?
I mean, I know what a water heater is, but why would you want to heat your hot water?
That's just what they call it. Well, that's just what I call it.
Well, it's just something my dad always made fun of whenever I say hot water heater. Like, why are you getting something to heat your hot water? It's already hot.
Well, for those people that might end up in the military, if you end up over in the Middle East, take your hot water heater, turn it off, because all the water coming into your building is going to be hot anyway. So you use the hot water heater for your cold water. That way you can actually have a warm shower instead of a hot shower because you don't have any cold water.
Okay, gang, I'll take a break. 2 minutes.
Well, another good one is a hose pipe.
So most of these switches are, we've already know the symbols. Y'all had to learn the symbols, right? I need to find all this. I need to change my thing over because I think the symbols chart inside the lab book is a little better than the one in the textbook thing. So pressure switches, we can set them to sense when pressure gets above a certain level. We can set them when they get below a certain level. So most compressors that have a tank on them, they actually have 2 pressure switches or 1 pressure switch that it's inside one unit. It has 2 pressure switches. What's one of them? One of them is for low pressure, and one of them's at high pressure, right? And the compressor uses an intermediate motor, duty motor. Most compressors don't have a continuous duty motor because they don't have to run all the time, right? And then it'll come up and run when it gets below a certain pressure, and then when it gets above a certain pressure, it cuts off, and then you operate between the low and the high pressure of the compressor of the tank. Now they do have some continuous flow compressors that do run all the time, but most shops don't have those things. Those are very expensive.
Shoot, the ones at US Steel are continuous.
Now, some of
huge ones.
This is a true story. One of the ways you can track conduit, one of the tricks that you learn is that if you got a compressor available, you stick the nozzle down in your conduit and then you get the air and then you go over in the cabinet and you feel where the air is coming up. Over at the Curve Master, they ran 200 psi worth of air pressure over there because they used that to cool the rails off. So there was water quenched right after. The Curve Master is where they heat temper the crown of the rails. And this is the rails they use in curves because they take more stress. And they use an induction heater. So what they did is they air quenched it. So they air quenched it so it would set up the molecules and then they water cooled it. And they ran 200 pounds of pressure. It was something. And Dennis Ramsey was working over there. And Dennis went over there and was going to trace that. And he got one of those air hoses and he went over to the conduit. And it didn't have one of those things. It had a hand valve on it. So you turn the air on with the valve. And Dennis went over there and turned that air on, and the hose came out. He created so much force, the hose jerked out of his hand, and that hose like a big poor Dennis to death. And he's over there saying, "Shut it off, shut it off, shut it off." But we did find out where the conduit was. But that's a true story. So this is where we'll stop the lecture at. This, of course, the symbols, most of the stuff, so saying these are not gonna be on the test is not exactly true. Because just about everything that we've covered up to now, except for the daylight sensor, we've already had, right? So the pressure switches we've already talked about, the click switches we've already talked about, the selector switch we've already talked about, so those could be on the test. But like the joystick, this is the first time y'all seen the joystick, the daylight sensor, and the rest of the stuff, those will move to test 3. Are we okay? Any questions on what we've covered so far? So where's the review for the test?
It's on Blackboard.
Yeah, it's on Blackboard.
I'm looking at it right now.